Hello, human geographers. We are back at it again this evening to take a look at the first of many models that we'll be learning about during the course of cities and urban land use. Now, most of them are land use models. Tonight, we're going to be looking at models, patterns of population. We'll look at a little locational theory. So we're going to be looking at a few different things this evening. We start out by looking at the rank size rule. It's one of our vocabulary definitions. Here it is. In a model urban hierarchy, it is a pattern of settlement such that the nth largest settlement is 1 over n, the population of the largest settlement. So essentially what this is that it's a way of predicting population size within a model environment. Now, obviously, we know that basically no place is ever perfectly according to this. And so instead, we classify it as closer to rank size rule or something else. So essentially what this is saying that whatever the nth largest settlement is, let's say the 5th largest settlement. So the 5th largest settlement would be 1 over n, in this case 1 over 5. 1/5, 20%, the population of the largest settlement. So if the largest settlement was 1 million people, the 5th largest settlement should be 20% of that, 1/5 of that, so it should be 200,000 people. All right. It would then mean that, the second largest settlement would be 1 over 2, 1/2 that population. So if the largest is 1 million, the second largest would be 500,000. All right. And so it's just a way of predicting those things and saying that in an ideal urban setting, the population sizes will decrease as settlements go. And later tonight, we're going to talk about the impact of that. Now, Felix Auerbach was the first one to suggest that there was a hierarchy here in terms of population numbers. But George Zipf was the one who actually created the formula. And so it's actually sometimes referred to as Zipf's law in the event that we happen to see that on the AP exam. And generally speaking, it applies more to MDCs than to LDCs, but not always, as we're going to see. So we take a look at our visual. Okay, notice the fairly consistent decline for the United States. Okay, that it kind of very gradually declines as the settlements decrease. And that is characteristic, at least in this sense, of rank size rule. When we take a look at it here in a couple minutes with our fun little quiz, we're going to see it looks slightly different than this. Hey, but when we compare it to Romania, the largest city of Bucharest, hey, there's a fairly steep decline from the largest to the second largest. And so we would actually characterize this as the law of the primate city, or primate city rule, or what we're going to call it on the next slide, urban primacy. So just be aware of that word primate or some kind of derivation of that with regards to cities and states that don't follow the rank size rule. So let's take a look at that. A lot of times it's in LDCs, it's in less developed countries, especially of the periphery. And what we typically see is that the largest city is overly populated, like disproportionately large in terms of population, in terms of influence, in terms of services provided, all those different types of things. Way more than twice as much. Again, according to rank size rule, the second largest city should be half the size. So the largest city should be twice as big as the second largest, according to rank size rule. Under the law of the primate city, under primate city rule, that's different. The largest city is way more than twice as big. And so what is a primate city? Once again, it's one of our vocabulary terms. It is the largest city in a country that is much greater then the second largest, overwhelming the rest of the country in terms of population, as well as cultural and economic importance. So we mentioned that a lot of times these are cities that are in LDCs, periphery states, and especially in former colonies, these are cities that were the former colonial capitals when they were colonies. A lot of times they are on the coastal part of that state if they have access to water. But that's what we tend to see, and we're going to look at a couple examples. But there's a couple really distinct examples of MDCs that have a primate city. And we also see them in countries that do or have had in the past a very strong monarchy. So the examples we're going to look at on the next slide of London and Paris, well, those are states that have in the past had very strong monarchies. All right. Now, there is a third description. If there are two cities that are very, very large, like disproportionately above what they're supposed to be according to rank size rule, with almost equal population, doesn't have to be exactly equal, but way above what rank size rule says it should be, we classify that as a binary distribution. All right, binary meaning two. And so a good example of that is in India. New Delhi has approximately 25 million people. And again, like we talked about in our last lecture, the boundaries of where you draw the urban space dictates the number of people that are part of it. So you're going to see a lot of different numbers depending on your resource. So you have to be critical of that. You have to say, okay, what are we including? What are we not including? But in this case, New Delhi, 25 million, Mumbai, 21 million. Those two disproportionately larger. With New Delhi being the largest, 25 million, it should be Mumbai, the second largest, should be about 12.5 million, except it's 21 million. So it's way above that. So let's look at a couple other examples. So let's go ahead and take a look at some examples of primate cities from around the world. Now, while I'm doing this, I want you guys to try and come up with another example. All right, so let's go ahead and get started. Probably the best example of a primate city, like if I were on an FRQ and had to provide an example of a primate city, this is probably the one that I would use. Mexico City, with a population of closing in on 21 million people. The second largest city. Now, remember, according to rank size rule, that would put it at 10.5 million, about that. Second largest city is Guadalajara, with a population of less than 5 million. And that's a fairly substantial difference, all right? Because that would put it at, like according to rank size rule, about like the fourth largest city. If it's about 20 million and about 5 million, that's 1/4 the size. So that would put it at, the fourth largest city. And that's another good exercise to do with this. As we're going through these, take a look at the numbers. If the largest city is, let's use another example, Seoul, South Korea, with a population of close to 10 million. Well, the second largest city is Busan, with a population of 3 million. And so let's take a look at that, all right? And where would it fall on rank size rule? Let's simplify it a little bit. Let's say 9 million to 3 million. Well, that's 1/3 the size. So it's the size of the third largest city, when really, in actuality, it is the second largest city. And so we're looking at those examples. So as we're doing this, one, come up with another example that's not on this list. And you guys already have the list in front of you. Okay, but also calculate where that state would, or that city would be based on the rank size rule. Next one is Luanda in Angola, with a population of about 5.5 million people. The second largest city is Huambo, with a population of 1.2. So if we said 5 million to 1 million, that's 1/5 the size. Bangkok in Thailand, with a population of about 9 million. Samut Prakan, with a population of 1 million, closing in on 2 million. All right. So if we said, about 10 million to about 2 million, we're rounding up to make the math a little bit easier. That's 1/5 the size. It should be the 5th largest settlement according to rank size rule, but it's really the 2nd. London. So now getting into a couple examples of core countries, in this case one with a history in the past of a very strong monarchy. They don't have it anymore. But London with a population of 10 million, the second largest is Manchester with a population of 2 million. Again, 1/5 the size. Paris in France, population of 10 million closing in on 11 million. Lyon with a population of 1 million. All right? Look at that stark divide. If we're simplifying 10 million to 1 million, that is 1/10 the size. That should be the 10th largest settlement. It's the 2nd. And then finally, Copenhagen in Denmark with a population of 1.2 million, Aarhus with 242,000. 1/6 the size of it. Now, again, come up with another example, but I would say even more importantly than that, what are some of the problems that might come about as a result of this? If the largest city has just the disproportionately large population, what are some of the things that might be challenges for those cities as they move forward? Now, we're going to talk about this in class. We're going to talk about how the United States ranks with this. We're going to look at some world populations and things like that. So we're going to take this to another level and be able to discuss that in class. But I want you to think about that as we're going forward. Now, shifting gears a little bit, we're going to get into a couple, leaving rank size rule behind, we're going to get into a couple other models. We're going to talk about the gravity model, which we've discussed in the past before, but also we're going to talk about central place theory. So here we go. Before we can talk about either of those, there's a few definitions that we have to characterize. First off, we have to start with market area. Now, this is a term that we've heard throughout the school year, but now it's actually part of our vocabulary lesson. So market area is the area surrounding a central place from which people are attracted to use the place's goods and services. It is also sometimes known as a hinterland. All right. Now, market areas, because you have a central point, they said a central place, and you have an area surrounding that, going all the way back to unit number 1, what's that a good example of? What kind of region would a market area be a good example of? And hopefully you said that it'd be a good example of a functional or nodal region, because we have a center point and so far around that central point from which people are attracted to use an area's goods or services. Now, market areas vary based on a lot of different things, but 2 things in particular are range and threshold. Range is the maximum distance that people are willing to travel to use a good or service. Okay? For example, there's a couple ways that we can classify this. Okay? We can classify services as being high range, meaning that people are willing to travel very long distances for that service. For me, that's Cracker Barrel. Okay? I'm willing to drive to another state in order to go to Cracker Barrel. Now, we have Cracker Barrels here in Las Vegas, so I don't have to do that anymore. But I was willing to do that. People are willing to drive across the country to go to White Castle and Whataburger and things like that. Hey, and people are willing to travel here for things like In-N-Out. So most fast food probably doesn't have that high range, but maybe something does. So can you come up with another example of a high range, something that people are willing to travel a very long distance for? And on the flip side of that, there's low range. People are not willing to travel very far for whatever that is. Grocery store, for example. Are you going to drive all the way across the valley to go to, a Smith's or Vaughn's on the other side of the valley? Well, no, you're going to go to the one that's closest to you. All right. Now, if you're more of an Albertsons person and you drive past Vaughn's to get to Albertsons, that's a little bit different. We've got some preferences. Okay, and that's why things are going to vary a little bit with that. Okay, there's an element of loyalty with that. There's an element of competition to market area as well. Now, flipping to the other side. And I want you to come up with other examples. What's another example of a high range service? What's an example of a low range service? On the other side, we have threshold. Threshold is the minimum number of people needed to support a service. Again, just like with range, we have high threshold services. We have low threshold services. A high threshold means you need a lot of people in order to make a profit. For example, professional sports. On the other side, we've got low threshold. You don't need a lot of people. Okay, for example, a jewelry store. One person comes in and drops $1,000. That might be the only sale they make that day, but that's good enough. So what are some other examples? So if you are a business owner, okay, and one of my favorite things about this unit is that a lot of our students want to grow up and own their own business. And this is really applicable to that because you can't just put your business anywhere. You have to do some research if you want your business to be successful. So ideally, one of the things you would look at is calculating your market area, your ideal location. Okay, so you start out by calculating your range. For example, okay, how far are people willing to travel for your service? The example I give you there is 10 miles for a pizza. Now, it is my dream one day to own a scented candle shop. Okay, I've already got a small collection going in my classroom, but one day I would like to own a scented candle shop. Now, it's not going to be a boring scented candle shop with just vanilla. It's not going to be just that. Okay, we're going to have awesome flavors. Okay, the best flavors. Okay, we're going to have pizza scented candles. We're going to have freshly cut grass. Have you ever smelled freshly cut grass? It's amazing. We're going to have bacon scented candles. It's going to be sensational. I wish I could say that I came up with that joke. That came from a student. So props to that student. But because of that, because we have such awesome scents, people are going to travel from miles around for Mr. Pileski's sensational candle shop. So my market area will be fairly large. Range, pretty high because people are going to be willing to travel fairly long, far distances to get a bacon scented candle. Then I have to calculate my threshold. Okay, how many people do we need to use our service to make a profit? Now, being a scented candle shop, I don't anticipate that we're going to have a ton of foot traffic. So I'm going to have, some more expensive candles. That way when people come in and they pay more, the vanilla will be cheap because you can get vanilla scented candles anywhere. But the bacon scented candle might be a little bit more expensive. And so I don't need quite as many people as a result of that. Okay. Now I also have to look at demand because if everyone's coming in and buying the vanilla, then I'm going to need, my threshold is going to have to be higher. All right, because they're the cheaper candle. But if everybody comes in and buys bacon and we're sold out of the bacon scented candle, well, I don't need as many people. So I have to kind of take a look at where the demand is as well. And then I can draw my market area. Okay. So using the example that we've got here, hey, people are willing to travel 10 miles for a pizza. Hey, we need $5,000 a week in order to be profitable. People are going to spend about $5 a week on pizza, so we need 1,000 people. So we draw our 10-mile radius around our central point, around our pizza shop. Hey, and if there's more than 1,000 people within that market area, we should be fine. We should be able to turn the profit that we need. Okay? But when it comes to things like calculating range, you have to ask yourself, what modes of transportation are we talking about? Because are people going to walk 10 miles for a pizza? Well, no. And so you have to take those modes of transportation. Are we talking about personal cars? Are we out in the suburbs where everybody has their own car? Are we in a city where most of it is going to be public transportation, buses, subways, walking, things like that? Because that's going to influence it. You have to take into account things like competition, other people, and how much competition there's going to be. Now, we've mentioned the gravity model a few times throughout the course of the year, but it comes back in again when we're talking about market areas and interaction between people. So here's the definition once again from the gravity model. A model which holds that the potential use of a service at a particular location is directly related to the number of people in a location and inversely related to the distance people must travel to reach that service. We're basically talking about range and threshold. The longer the range, the less likely they are to interact, less interaction. The shorter the range, more interaction. The more people you have, the more interaction therefore you should be. Okay? So you might locate close to, if you're a high threshold industry, you might locate where there's a lot of people. Whereas a low threshold service might be able to locate out in the suburbs where there's fewer people, lower population densities, lower concentration, things like that. And this is a great tool for us because it can be calculated. We can actually calculate this using this formula, the population of one area, the population of another, and the distance between them. Okay? But that doesn't necessarily apply to services because you're just trying to look at the number of people within your market area. So that applies more to like interaction in the forms of migration and things like that. But when it comes to this is something that we can use to influence the location of our industries. And so you want to take a look at that. You want to take a look at how far people are willing to travel. Hey, how many people are living in an area? These are all things that would have to be considered by you, the business owner, or me, the owner of a sensational candle shop. Now, the last model that we have to look at today is central place theory. Okay, it is based off a guy by the name of Walter Kristaller. You absolutely, without a doubt, need to know his name. And he wrote a book called Decentral Places in Southern Germany in 1933. Okay, so about 100 years after von Thunen, but actually in the same country. Okay, von Thunen was German, so too was Kristaller. That's what his book is based on. And so you will sometimes see central place theory labeled as Kristaller's theory. Here is the definition of central place theory. A theory proposed by Walter Kristaller that explains the distribution of services based on the fact that settlements serve as centers of market areas for services. Larger settlements are fewer and farther apart than smaller settlements and provide services for a larger number of people who are willing to travel further. Okay, so to bring some of this back in, the urban hierarchy has different services. So hamlets, villages, towns, cities have different services based on the fact that people are willing to travel further or not as far, depending on the service, okay, and the number of people needed for that service to be profitable. Okay? For example, okay, Las Vegas has an international airport. All right? The airport that is in Calnavari, okay, people don't travel nearly as far for that airport because it doesn't serve as far of a distance. Okay, that service that is provided, it doesn't go as far. All right? And so little towns, for another example, little towns might have like a family doctor, okay, that handles most things in the town. But if you have a need for some kind of specialized service, you need a neurologist, you need an oncologist, you need some kind of specialized doctor, you're probably going to have to travel to a big city. Because those services, like being a neurosurgeon, okay, being a neurologist, a brain doctor, hey, you need to have a lot more people in order for your business to be profitable. Hey, if you're a neurologist in a small town, not everyone there is going to have brain problems and going to need a neurologist. So instead, what you're going to see is that those areas that need, okay, more people are going to locate in those areas with more people. Okay? Now, a neurologist might be, because the price is very high or the payment is very, very high, it's actually classified more as a low threshold. But you need a lot more people in order to meet that threshold. So this can get very, very, very confusing. All right? So you just have to think about, okay, what's our range, what's our threshold, and start with that. So let's go ahead and take a look at the visual that corresponds with this model. Just like von Thunen had concentric rings, just like Weber had the locational triangle, what you see in the top left corner there is the model for central place theory. It is a series of hexagons. So if you take a look at the key, at the center point there, you have that star. That's the city. That is our largest urban settlement, which means that it's going to have the greatest number of services and services that people are willing to travel a very long distance for, and that you need a lot of people to sustain that service. Then notice that there's varying levels of hexagons within this. So the hexagons that surround towns are smaller than the one large hexagon for the city. The hexagons that surround villages are smaller still. And the smallest hexagons are the ones around hamlets, because you have fewer people, which means that the services that are able to locate there, maybe like a general store, a grocery store, a family doctor, just very small things that apply to a lot of the people in that hamlet are able to be supported by that. Okay. Now, the one on the right is a much more advanced version of that. And what you see at the bottom is the explanation for why we use hexagons. Okay. So if you take a look at the far left, circles, there are gaps around that central place. Now remember, we said that central place theory is a great example of a functional region. And a perfect functional region would be a circle. But with circles, you have gaps. And those gaps suggest that there's no way we're going to provide a service there. Well, we know that that's not true. And then there's overlapping. And with squares, they nest together. They come together and there's no gaps, there's no overlapping. We call that nesting together. Okay? But the distance from the center varies greater depending on where you are on the edge of the square. So hexagons were a compromise between the two. They do nest together like squares, but it's a little bit more equidistant from the center point out to the edges than with a square. So that's kind of the explanation there. Now, just like with von Thunen's model, just like with all of our land use models, there are assumptions that have to exist in order to make these work. So let's take a look at them, and you'll notice that they're very similar to the assumptions that we talked about with von Thunen. Hey, flat and no physical barriers. Soil fertility is the same everywhere. Population and purchasing power is the same. It's a uniform transportation network. Hey, from any given place, a good or service can be sold in all directions out to a certain distance. That's your market area. And so they're very similar to the assumptions with von Thunen. And just like von Thunen, Christaller knew that these assumptions were not realistic. All right? But, just like von Thunen, if they're unrealistic, does that mean that the model doesn't work? That it's pointless? Well, no, of course not. Okay? It still works because it's about the location of services. Von Thunen was about the location of the primary sector, agricultural activities. Okay? Weber was about the location of industry, secondary sector. Christaller is about the location of services. That there will be a center point, and there's only so far out from that center point that these services will go. And within that, you need a certain amount of people who are willing to drive a certain distance in order to do that. So let's look at a specific example now with Major League Sports.